Hello everyone, I'm back with the revision series of class 10 Maths ICSE board. Today I'll be discussing matrices. Matrices is a rectangular array of numbers, rectangular arrangement of numbers, and it is denoted by capital letter. Okay, whatever the letter would be, it's like this, denoted. Okay, now what does this mean? A matrix A whose elements are Aij, where I represents column, I is a row, I is a row number, and J is the column number. Just remember RC. Here also M is number of rows, N is number of columns. It is always RC, RC. Now what is R? R is, okay, not here. Let me just see. So say A first row. Row, just remember these are rows. The horizontal lines are rows. Obviously, vertical will be column. So don't try to remember rows and columns both. Okay. So just rows. Horizontal lines are rows. So this is row 1, row 2, row 3. Suppose here. First RC. So first row, let me write for first row. Okay, for the first row. Here for the second row, third row. Fine. So I have written for the rows, first row, second row, third row. Now let me fill the columns. First column, second column. Vertical will be column, obviously. Horizontals are rows. So second column and third column. Here first column, second column, third column. Fine. Then with practice, of course, it becomes easy. Third row, first column, second column, third column. Fine. So this is a matrix. So these are the elements of matrix. 1, 1, 2, 1. I is row RC. Remember RC. Row column. Here also M and N RC. Fine. Now what is M and N? That's the order of the matrix where M represents number of rows, C is for number of columns. Here we see there are 3 rows and 3 columns. Got it? Okay. This is about matrix representation. Types of matrix: row matrix. Row if there is only one row. Okay, fine. Only one row. Then we have a column matrix when there is only one column. Only one column. First row, first column. First row. This is the second row, first column. Third row, first column. Right? Rows are 3, one column. Row matrix, column matrix. Then we have zero or null matrix. Zero or null. Zero or null matrix. These are matrices whose elements are all zero. Okay, these are all rectangular matrices, elements are zero. Then we have a square matrix. Square matrix where number of rows, square matrix where the number of rows is equal to number of columns. Fine. So first, these are rows, first row, second row. 1, 1, 2, A, 2, 2. This is a square matrix. Under this only we get this identity matrix. Identity matrix belongs to square matrix. Identity matrix is denoted by letter I. It is a square matrix, fine, of order. It can be order 2, order 3, whatever. Square matrix whose diagonal elements are 1. The other elements are 0. These are diagonal elements. Diagonal elements 1, other element 0. That's an identity matrix. Okay. Then if one more is transpose of a matrix. That also was asked one year. I have pulled up PYQs. Transpose of a matrix. If A is say 1, 2, 3, 4, 5, 6, what is the order of A? How many rows? 3 rows, 2 columns. RC. Fine. So transpose of A is that matrix where the rows and columns are interchanged. That means the first row has to be written as first column. Second row will be written as second column. Third row as third column. This is the transpose of A. Order becomes, see, 2 rows, 3 columns. The order has become reverse of that, right? M into N. It has become N into M. That's the transpose of a matrix. Now, algebra of matrix, that means addition, subtraction and all. So, A plus B, when we add two matrices, okay, equal matrix also is there. Anyway, what is done for A plus B? Say 2, 3, 4, 5. We are adding. The order should be same when we are adding two matrices. Order should be same. So 1, 3, 2, 5. When you add these two, corresponding elements are added. So 3, 6, 5, 10. Corresponding elements are added. For subtracting also, corresponding elements are subtracted. A minus B, first minus second. Okay. Equal matrix. Two matrices are equal if first their orders are same. First of all, their orders have to be same, and secondly, the elements have to be same. Elements are correspondingly equal. Fine. So if I say x, y, p, q is equal to a, let's take a number, some numbers 2, 3, 6, 9. These two matrices, first of all, we see orders are same, and if they are equal, their elements have to be correspondingly equal. That means A11 here should be A11 here, A12 will be A12, and so on. Fine. Then they are equal. All right. Then addition of, where we discussed, so A plus, there's something called zero matrix or null matrix, all elements 0. A plus minus A will be actually a zero matrix. 0 is additive identity. Okay, and this is additive inverse. Additive inverse, which gives us additive identity, which is 0 0 0 0, all elements 0. Fine. Then A plus B is same as B plus A. That is true for addition. Also associative. A plus B plus C will be same as A plus B plus C. Okay. Now comes multiplication of two matrices. When we multiply two matrices, what happens? And when is it possible to multiply? So if order of A is M cross N, you're multiplying it with a matrix B, its order. Here, this should be equal to this. That means this has to be N. Fine, let me write it a little bigger. This has to be N. Cross, this can be anything, no problem. Here, this can be anything. But this RC, right? RC. So this C here, C of 1 will be R of 2. Clear? C of 1 should be equal to R of 2. Only then they can be multiplied. And the results result AB, its order will be M cross P. Fine. Let's take an example. Simple example. Let me take A, order of A. Let's see, 2 cross 3. Simple numbers. This is what is the order of this? I said 2 cross 3 and I took. Let me take this. So order of this is 3 cross 2. Okay. Multiply by the order of the next one has to have, this is C, row has to be only 2, column may be anything, so only 2 rows. Okay, so 1 5, only 2 rows, column can be anything. Okay, 3 column, let us take 0 3 1 and -1. Order is 2 cross 3, correct? These two have to be equal. Since they are equal, we can multiply. And the results order, we will see what we are getting. Now, how to multiply this? Let me see. What we do when you are multiplying two matrices, take the first column, multiply by the first. Take the first row, multiply by the first column. That will give you the first element. Till you are done with the first row, you are not done with the first element. Till that, first you need to finish off with the whole row. How? First by first, second by second. That will give you the first element here. Let's do that. 1 into 1 plus -1 into 3. So -3. That is the first element. Then continue like this till you are done with all the columns. 1 into 5, -1 into -1. Then 1 into 0, -1 into -1. Got it? Okay. Then same thing we'll do with the second row, each column. Fine. Take the second row, first column. So 0 into 1, 0, 1 into 3, 3. That gives me the first element. Then 0 into 5, 1 into 1, 0 into 0, 1 into -1. Okay, we are done with the second row. Now the third row goes 2 into 1, 0 into 3, 2 into 5, 0, and 2 into 0, 0. This is 0 only. What we see, the results order is 1, 2, 3, 3 rows. 3 rows and 3 columns. You may simplify. Fine. So to multiply first row, first column, till that is done, you are getting only the first element here. First row, second column, second element, and so on. Okay, this is how we multiply. And the order, this is important, order RC, RC. So C1 should be equal to R2, and the result will have 3 cross 3 here, M cross P. Order of the result will be. Okay, now A into B is not same as B into A. First of all, it may not be possible to multiply if the orders don't comply. A into B is not same as B into A. It will not be same. That's all about the theory part. I have pulled up a few PYQs. I'll do one or two, I think, because I've already explained almost everything. There's a question like this. Oh, what is happening here? This okay. Suppose let me take a question like this. A is given to be 1, 2, 3, 4, and B is given to be 6i. Fine. You're asked to find A square plus 6i. A square plus B. Now what is a square? To find this, we first need to find a square, isn't it? What is a square? A into a. That will be a square. So a into a. 1, 2, 3, 4. 1, 2, 3, 4. See, orders are feasible. This is equal to this. To multiply, first column, first row, first column. Let's see what we get. 1 into 1. 1 plus 2, 3, 6. So 7. 1 into 2, 2. 4 2s are 8. 12. Then first row is done. Now with second row. 3 1s are 3. 4 3s are 12. 15. 3 2s are 6. 4 4s are 16. This is a square. Fine. Its order is 2 cross 2 only. These two. So a square. Let us write b. I mean 7, 12, 15, 22. This is a square plus 6i. I is 1. Now order has to be same. Otherwise we cannot add. So 1, 0, 0, 1. Fine. When you multiply by 6, what will happen? The whole, each element will get multiplied by 6. And now while adding, corresponding elements are added. 6 and 7, 13. 12 plus 0, 15 plus 0, 22 plus 6. That is the answer. Got it? So I've shown you multiplication, I've shown you addition. I don't think, okay, some like x plus y sometimes they ask. Let me see if I have any question like that. Okay, one more. Minus 2, 0, 3, 1 times minus 1, 2x plus 3 minus 2, 1. This is given to be 2y3. You're asked to find x and y. Okay. So let us multiply first row column. So first row till it is over, we get the first element only, right? Minus, so this is 2 and 0. Now first row, this is done. So now the second row, 3 minus 3. So we get only 2, that is 0 only. Minus 3, 1 into 2x plus 2x. Correct? Plus, you could have first checked whether it is feasible or of course it has to be because they have given. Anyway, this is 2 cross 2. This is 2 cross 1. These two are equal. So it is, this can be multiplied. Here plus this becomes 3 is multiplied by each element. So 6 and 3. Here also 2 gets multiplied by each. So 2y and 6. Now first add 2 minus 6. So minus 4. Here minus 3 plus 3 0. This is 2x. This is equal to 2y and 6. Two matrices would be equal if and only if they are the elements are correspondingly equal. Hence 2y is minus 4, y is minus 2 and 2x is 6. So x is 3. I hope this is all. Not much is there in this chapter. It's an easy chapter. So while doing, just be careful what you're doing. They'll ask about order and then multiply, add, these only, right? So easy chapter. Don't go wrong in these questions. Okay, if you're careful while doing, you'll not go wrong. So maths, the trick to do well in maths is those which you know, those you have to do correctly. If you do not know, then you may try, but which you know, you have to do them correctly. Okay, and matrices should be one of them. Okay, okay, then I hope you practice this well and do not go wrong in these questions. Okay, I'll end it now. Thank you for watching.